Okay, so in this video we are going to review how to solve quadratic equations with three terms by factoring. So we're going to use the area model here. So when I have a quadratic and it has three terms, it needs to be written in standard form, ax squared plus bx plus c. So when I get it in that form, so this should be a 0, so let's make this 0 here. Not y equals, we're going to make that a 0. And so first thing I want to do is I want to rewrite this expression on the right hand side as the product of two expressions. So to do that, I use an area model or a generic rectangle. So let's just do a little bit of review here. So if I have let's say I have this, something simple, and I were to multiply this out. Now, the FOIL method, which I don't like, would say I take the first term times this term, so the first, that's x squared, this times that 3, which gives me negative 3. Then I would take the 2 times the x, 2x, and I would get a 2 times negative 3. So I get 4 terms. And so, in my generic rectangle, when I go to solve these types of equations that are quadratic through terms, I want to make 4 boxes. And notice how whenever we multiply these out, we always have these 2 terms that always combine to give me the middle term at the end of my multiplication. So this is how we do this. So I'm going to take, this is the A term, this is the B term, this is the C term. A is really going to be the number, the coefficient in front of x squared. And so I take the A term, I'm going to put it in this top left hand box. And I take the C term, and I put it in this bottom right hand box. Now, one little trick is this. This square, these two squares here, so I'll make them in red, these two squares represent the 2 terms I add together to get my middle term. So if I were to factor this, the 2 terms that would go in the red boxes would be negative 3x and 2x. And another thing about this box is when I multiply the diagonal in blue, I should get the same product as the diagonal in green that connects those 2 red boxes. So one way we do to organize this is we draw a diamond. I draw an open-ended diamond or a big X. And so what I do is this. So the number up top is always going to be the product of A times C, and the bottom of the box, or of the diamond, gives me the B term. So I take A is the leading coefficient, so 1 times 40, or I multiply these together, so x squared times 40 is 40x. And having the x in there is important. Now, the B term, the sum of these boxes will be the middle term, so this can be 13x. And so what I want to do is I want to determine what 2 terms multiply together to give me 40x squared and add to equal 13x. And so I know to multiply to get an x squared term, I have to have an x in one term and probably an x in the other. So I want to know what these coefficients are. So what I do is I take the number 40 and I'm going to write the different ways they multiply 2 numbers together to get 40. So we get 1 and 40, get 2 and 20, not 3, 4 and 10, 5 and 8. So those are all the ways I can multiply to get 40. And so now I want to say, well, which one of these combinations gives me 13 when I add them together? Well, the only option is 5 and 8. So I'm going to put a 5x here, right? And an 8x here. It doesn't matter which box. Notice 5x times 8x is 40x, so the diagonals are the same. Now, to get the factors here, I'm going to take this column here. So let's highlight this in green here. I'm going to take this column here, and I'm going to say, what is the greatest common factor? And so the greatest common factor of x squared and x is, x squared and 8x is x. And so I know x times x is x squared. So that's essentially the dimensions of this square. So if this is x here. And so what do you times by x? Get 8x. So this is 8. It's positive. And then I think we can see what goes up here is a 5. And so what I get up here is I get the equation now is going to equal x plus 0 equals x times 5 times x plus 8. Notice, a is 1. The numbers that I use to complete my diamond here are the numbers in my factors. So when I have a value of a and it's equal to 1, that's a trick. If I just come up with the numbers that multiply to equal a times c and add equal b, those numbers go into the factors. Now to solve this, I use the zero product property, which says when two things multiply to equal 0, then one of these has to equal 0. So either x plus 5 should equal 0, or x plus 8 equals 0. And so we can see that one answer is going to be negative 5, and the other answer is going to be negative 8. I check my work by plugging negative 5 in for x here, verifying equals 0, and plugging negative 8 into the equation, and verifying that it equals 0.